A positive integer n is a nice if there is a positive integer m with exactly 4 positive divisors, including one in itself, such that the sum of the 4 divisors is equal to n. And how many of the numbers in this list are actually nice? Okay, so just make sure you understand the question. Like we are looking for a number that has 4 divisor, right? And when you add those 4 divisors, so we are gonna get some of these numbers in this list. Okay, so like just to recap, like if you are looking for the divisors, we look at the prime factorization usually. Let's say we have 2 squared. So divisor of this guy will be 2 to the 0, like 2 to the first and 2 to the second, which is just 3 divisors. So you could have any power of 2, including 0th power. So which is why we add 1 to this exponent. So if I have 2 to the third times 5 to the, like, say, second. So divisor of this could be like somehow 2 to the a times 5 to the b power. And then a could be 0, 1, 2, or 3. And then b could be 0, 1, and 2. So we have 4 choice for a, 4 power of 2, and then 3 choice for b, which is going to be 12, or we just do that like we add 1 to this exponent and then 1 to this exponent and multiply those, which is going to give us 3 plus 1 and times 2 plus 1. So again, this is just a recap for the counter number of divisors. So in our case, like we are given that the number m has 4 divisors. So like, and then if there is a number m, so has a 4 divisors, so it could be a prime number to the 3rd power, because if this is the number, my divisor will be p to the 0th power, p to the 1st power, and p to the 2nd power, and p to the 3rd power. So this is one case you could have, which is p is a prime number, like 2, 3, whatever. So these are going to be 4 different divisors. Or the m could be the product of 2 different prime numbers. So let's say 2 and 5, or 2, 7, or 3, 7, and stuff. So if there is like such a number that is a product of 2 different primes, that could give us also 4 different divisors, because this has a power of 1, this has a power of 1. When you find the number of divisors, we add 1 to this exponent, which is 2, 1 to this exponent, which is also 2. So we have 4 divisors, and you can even list them. So the first divisor is 1, because 1 is dividing everything, including m. And then another divisor, let's say p, and then the next one is q, and then the 4th divisor is p times q. So these are my 4 divisors. And then the question is asking us the sum of these divisors. So 1, like p, q, and p times q is gonna give us a number, which is gonna be our n. And we wanna find the number of n's basically. So like, if you see this is like product of 2 variable, and then those 2 variable are given as a linear term, that's kind of a job for the assignment. So we can just try factor in this expression. So that is equal to n. So to get p and q, so we should have like p and q right here as well. So I'm gonna start with p's and q's. To get p, I need to multiply p by something right here to get p, which is gonna be 1, and the same idea with the q. And then when you multiply once, you get also this one, so which is good. So if you want to factor this guy, this is what we got. So the n is the number that we get when you multiply prime number plus 1, another prime number plus 1. So now just remember, like, prime could be 2 or any odd like numbers that we could choose for those prime numbers, but we could have like p as 2 as well, or q as 2. Let's say p is 2, because it doesn't really make any difference if I choose q is 2. And then I cannot choose both 2, because that will be the same prime, which we don't want, because we're not get 2 different primes. If one of these primes is 2, so that will give us 2 plus 1 times q plus 1. And then this is going to be our n. So this is 3, and then plus 1 is equal to n. So we know q, like, it's going to be odd number. Odd plus 1 is going to be even number. So this part is even number. So if you multiply 3 by a even number, n has to be at least multiple of 6, because it is divisible by 3 and it is even number. So it has to be divisible by 6. So when you look at the option, So 201, like 201, when you add a digit, that's divisible, like multiple of 3, and that's divisible by 3, and that's also even. So that's gonna be a number that is divisible by 6. So 2010. And if you add 6 to this number, so you get 2016, and that is gonna be another number that is also divisible by 6. So then if you keep adding another 6, you will get more, but there is no other numbers in that list. So then these are the two numbers we have to check for this first case when the P is like 2, right? So, and we know that the one of the factors of n has to be 3. So again, these two numbers should be equal to like 3 times like a prime number q plus 1. If you divide by 3, so that should give us 6, because 20 divided by 3 is 6. That's going to be 2 left over. 21 will be 7 times 670. And then if you divide this by 3, so you will get 6, 7, and then that will be 2 is equal to q plus 1. If you subtract 1 from both sides, so to get the q, so my q's might be 669 or 671. But you know, this is already divisible by 3, so it's not a prime number, so we don't have to worry about that. And the next number we have to check, like, to see if this is a prime number. So if I try like first prime numbers 2, 3, 5, 7, it doesn't look like it's dividing this number. But 11, so if I divide this by 11, that's going to be 66. So you will get 1 left over, which is going to be 11. So this is divisible by 11. So that's 11 times 6. The let me see, 6 times 11, that's 66. That's going to be 61. So this is not a prime number. So which means for our first case, when the one of the numbers is 2, then there is no such a number in that list that actually be nicer. So then we are going to move on to second case where the both of these product is going to be the odd numbers. Like, I mean, for the P and Q will be odd prime. So if I choose P and Q, like P and Q is odd prime instead of 2, so then P plus 1 is gonna be one factor, and then Q plus 1 is gonna be another factor that will give us a number n. That's we are gonna call nice. So since P is odd number, one more is gonna be even. So this is also the same thing. So that's even times even is even. But since this is even, that's at least divisible by 2. This is also at least divisible by 2. So the n has to be divisible by 4, right? So the n is divisible by at least 4. So when you look at the list that we have, like 2008 is in first number that we can kind of see easily. That's divisible by 4, but that's not in the list. So the next number is 4 more. So that's going to be 2012, and then 4 more will be 2016. So this number didn't work out for this case, but maybe we can kind of get this work in this case, but let's check those. But at least we know there are at most 2 numbers. So like in this case, we want to get 2 different primes that will give us one of these 2 numbers. So in that case, like this is even number, this is like, 2 different even numbers that will give us one of these numbers. But since this is divisible by 4, so one factor should be at least 4, right? Because I cannot get a 2 and something, because if I choose one of these factors 2, so P has to be 1 or Q has to be 1, which is not a prime. So P plus 1 or Q plus 1 has to be at least 4. So if I divide this by 4, which will give us 4 times 503. And if I divide this by 4, so you will get 4 times 504. So like now this number 4 times 503, right? But we have to know like even times even, but this is even. So P plus 1 is 4, and then Q plus 1 is 503, but that's not even, so that doesn't work. And then I cannot make 2 times 1006, because if I do that, P or Q will be 1, which doesn't work. So which is why 2012 doesn't work. And for this 2016, 4 and 504 does work, because if this is 4, that means P is 3, and Q plus 1 is 504. That means Q is 503. So that is gonna give us actually a prime. So that does work. And then we can try 8 and like 252 as well to see if that works. But at least we know 2016 does work for this case. So we have only one number in that list that is a nice actually. So here's my challenge for you. Can you find the next smallest number larger than 2019 that is also nice? Okay. And share with me in the comments below. I'll see you in the next video.